One of the things which I spend a lot of time dealing with is in fact looking at environmental science and hands-on activities. And we've all heard about greenhouse gas and climate change. Here is a model that I have of carbon dioxide. And one of the reasons carbon dioxide is the greenhouse gas it is because of vibrations. And CO2 molecule vibrates very much like that at a particular frequency. And that frequency matches infrared. So infrared light, infrared radiation has a particular frequency, and CO2 vibrates at that frequency. So infrared light, infrared energy reaching the planet excites carbon dioxide in a very particular way. And that's why it picks up that energy. That energy gets translated into heat, and that's the source of greenhouse gases. I'll just very quickly do one little demonstration. We'll take my special CO2 exciting device. So I've got two of these, two CO2s, very much the same. And if I vibrate the stick at the right frequency, I'll get the CO2 to vibrate. If I just add now a little bit of weight to one of those, I'll change the frequency. So now I can get the top one to vibrate at one frequency, but the other one's not really vibrating. If I go a bit faster, I can get the bottom one to vibrate, but not the top. And so different molecules with different masses, different atoms, will vibrate at different frequencies. And that's one of the things behind our use of pH indicators, those coloured ingredients that we add to tell if something is an acid or a base, if it's alkaline. Those chemicals in an acid get protons added to them. That makes them heavier. They vibrate slower. They change their colour because of that. And if you look at all of the pH indicator charts, you'll find most of them, almost all of them, will become red at an acid. And that's because those protons are making them heavier and vibrating slower, which matches the red end of the spectrum.